I see algorithms everywhere, and by the end of this talk, on my latest research finding on algorithmic perceptions, I hope you will too. Not only you will be more aware of the impact that algorithmic decisions have on us as humans, as workers, and in our society, you will also learn some ways to integrate the ethics and perceptions of algorithmic decisions into the research that you do. I am a human-computer interaction researcher, and I started my research career by looking at how robots should work with people. When Uber was first introduced to Pittsburgh in 2014, that was a realization moment that sparked my research interest in the social impacts of more broadly defined algorithmic systems. These algorithms were making managerial decisions, giving drivers jobs, and influencing how much they earn. People express fear that robots and automation will replace their jobs. But actually, it is these invisible algorithms that are making more immediate impact on society by enabling new forms of work. But when I actually studied how Uber and Lyft drivers work with algorithms, I found out that technologies still have a long way to go. Problems that were arising from the gaps between algorithms' assumptions and actual human behaviors. Assignment algorithm automated ride assignment, giving little control to the drivers. So drivers created their own workarounds to regain the control. Evaluation algorithm used quantified metrics, but drivers felt that they were unfair because they did not account for important nuances and context. Finally, these algorithms worked entirely behind the scenes, failing to gain drivers' trust. This shows there is a hidden risk behind the algorithm's promises of efficiency and data-driven decisions, a risk that we are just beginning to understand. Using algorithms in these social functions risk invisibly and unknowingly reinforcing inhuman or sometimes unfair decisions. It is critical to investigate these social impacts of algorithm because they do not just apply to Uber or Lyft. Algorithms are everywhere. They don't just decide what we see online. Algorithms are making managerial and governance decisions in workplaces, schools, and cities. Some studies estimate that 46% of US employment will be transformed by algorithms within the next 2 decades. My goal is to answer the following questions. We already know algorithms can make our lives and our work more efficient. But how can it create communities and organizations in cities that are trustworthy, fair, and good to work and live in? There are 3 canonical challenges in achieving this vision. First, our algorithms increasingly perform higher levels of decision-making and discernment, going beyond just being recommendation engines, but also making managerial and governance calls. How should we expand theories of on psychology of algorithmic decisions to understand the impact of these algorithms' new roles? Second, there is an inherent gap between the hard-set mechanical nature of algorithms and then subjectivity of human nature. Technologies that try to fit people into tiny pre-programmed boxes for optimizations are likely to be rejected or have unintended consequences. How do we mediate this gap? Finally, the third challenge is codifying fairness in algorithms requires us to define what fair is, yet fairness is a socially constructed concept that depends on context. For example, in our work on an algorithm for fair donation distribution, we see there are people who believe that all donation recipients are equally deserving, versus those who believe that recipient with a higher need should receive more. So which fairness model do we operationalize in algorithms? In my talk, I will present 3 of my projects that address these challenges. The first project examines how people perceive algorithmic decisions compared to human decisions, especially in algorithmic management. Let me put this into context. Imagine that you apply for a job at Google, and you later find out that your application was reviewed by an algorithm rather than a person. How would this knowledge of the decision maker influence your perception? Would you feel that the hiring decision was fair or less fair? To test this, I conducted an online experiment using 4 test scenarios: work assignments, scheduling, hiring, and evaluation. I measured perceived fairness, trust, and emotional responses to the decisions. The scenarios that people saw were identical except the decision maker. Now I'd like to poll your opinions. So how many of you think that human decision will be viewed fairer than algorithmic decisions? Probably half of the room. And how many of you think that algorithmic decision will be viewed fairer? A little less, but probably a third of the room. So well, all of you are actually right in some way, because the answer is that it depends. The results show that perceptions of algorithmic decision depend on task types, in particular whether they are ones that people think algorithm will do better, or vice versa. When we piloted our test scenarios, people reported that work assignment and scheduling were mechanical tasks that algorithm could do better than humans. On the other hand, hiring and worker evaluation, which require subjective judgment, were tasks that humans would do better than algorithms. For mechanical tasks, both algorithmic and human decisions were perceived as equal. For more human tasks, algorithmic decisions were perceived inferior to human decisions in all measures. And these differences in perception, depending on task type, are important to note. Previous work on algorithmic recommendation treated all tasks equally and had mixed results. Some studies say people are less likely to follow algorithmic recommendations, whereas others show the opposite. And maybe task characteristic can be one of the mechanisms behind this mixed human behavior with algorithms. In our study, we also asked people to explain their ratings, and their answers showed different attributes people assigned to the decision makers. I won't go into detail in this talk, but I'd like to quickly highlight that people did mention algorithms' efficiency and objectivity for all tasks, but people just didn't trust that algorithm could analyze some factors in place of humans, such as nuances or work culture for human tasks. To wrap up, this first study suggests that depending on the task characteristics, algorithmic decision can be viewed as equal or inferior to human decisions. But in these studies, algorithms were treated as a black box. How do people perceive algorithmic decisions when they know more about the algorithm, such as the actual type of algorithms? The next study investigates these questions using fair division algorithms. Fair division algorithms are a subset of AI and computer theory research. These algorithms measure how much individuals' values or deserved limited resources, and then computes divisions. They are proven to guarantee fairness, which means that they satisfy different property of fairness in all cases. For example, the property of envy-freeness means that none of the players wants to swap their person with another because they find all the persons equally valuable. Many of these algorithms have been proven theoretically and mathematically, but very few have been evaluated from social perspectives. The notable exception is an anecdotal evaluation of a supposedly fair residency matching algorithm in which a doctor reports that the matching decision often seemed unfair. To explore this gap, we conducted a study to understand human perceptions of fair division algorithm. And we used a website called Splitit because Splitit applies fair division algorithm to social choices such as dividing tasks, chores, or rent. We brought people into a lab in groups and asked them to do a division task using Splitit. Each person indicated how much they value different resources, such as snacks or chore, and the algorithms allocated them accordingly. And we found that participants thought that their outcomes were somewhat fair on average, with a third of them saying their outcomes were not fair. The interviews suggest that the gaps between algorithms' assumptions and human behavior contribute to this perceived unfairness. Today, I will highlight 2 of the gaps, but if you'd like to see the full findings, please refer to our paper. 1, the splitted algorithm implement equity-based fairness based on individual preferences, but participants had more diverse concepts of fairness. Some preferred equality, everyone getting the same amount, or wanted to consider both individual preferences and objective market values. For example, this allocation on this slide was a fair distribution from the algorithm's perspective because each of these participants got the item that they wanted most. Even so, some participants thought that this outcome was unfair because the monetary value or quantity of 2 Starbucks was way lower than the others. The splitted algorithm also assumed that the individuals are rational actors who want to maximize their self-benefit. But in reality, some of our participants were willing to compromise to help others. They valued the happiness of the group as well as their own, and they wanted to accommodate others' needs. These people wanted the algorithm to consider these factors, or at least support these behavior. For example, one subject in our study said he wanted the software to collect the reasons why people want different options so that he could decide whether to alter his share depending on the reasons. To wrap up this study, I have explained that algorithm decisions were not as always perceived as fair. But it is very difficult to find divisions that everyone sees as fair. Maybe these participants would have seen any decisions in these cases as fair, whether the decision was made by algorithm or by people. Our second study experimentally explored this question by comparing algorithmic decisions with decisions made through discussion. We used task division, and people actually had to do the assigned chores. And you can imagine our kitchen lab was squeaky clean and smelled quite nice for a few months, as it was mopped and supplied with fresh coffee and lemonade every hour. So what did we find? The results suggest that discussion-based outcome was generally perceived as pretty fair and fairer than algorithmic decisions. Why was discussion effective? In the interviews, people said discussion gave autonomy to each group so that they could decide what's fair for them. In our case, some groups considered people's preferences and skills, whereas other groups tried to make everyone working for the same duration of time. In discussion, there was also social transparency. People could understand each other's preferences and make adjustments to increase overall fairness. To summarize, these 2 studies show even mathematically proven fair division algorithm can be perceived as unfair or less fair than human decisions. And the gaps between the algorithmic assumptions and human behavior might be contributing to this. So what does this mean? One implication is that we should think about how to mediate the gap between the algorithmic and human world, so we can combine the best part of human and algorithmic decision making. So in other words, how can you harness algorithms' efficient, scalable, and unbiased decision making, yet still accommodating altruistic behavior, different group norms, and human autonomy? The final project that I will present explores this question. We envision a system where the algorithm takes the role of processing data and mediating decisions, and people take the role of adjusting decision outcome to fit their group's values, norms, and context. To test this vision, we built a web interface that adds transparency and control to the algorithmic outcome from Splitted. Our interface first explains algorithmic assumptions and properties step by step. It then displayed each individual's input, the number that you see here, where each column represents one person, and then allocation outcome, the cells highlighted in green. We also showed algorithmic metric, in this case, each individual's gain utility from the allocation, or the degree that this allocation satisfies each individual's preferences. Then we allow people to interactively explore and adjust the allocation outcome as a group by clicking different cells to assign a resource to a different person. I want to note that the original splitting interface just showed the algorithmic outcomes, so our interface made a pretty big difference. We tested this interface through a within subjects experiment using a goods division task, and measured how transparency and control influences perceived fairness. This graph shows how people perceived fairness changed depending on whether they thought their initial outcome was fair or not. Algorithmic transparency had a paradoxical effect. It increased perceived fairness among those who initially found their outcomes less fair, but only marginally. And it decreased perceived fairness among those who initially found their outcomes fair. And having control over the algorithmic allocation universally increased the perceived fairness. And our interview results help us understand why. Given the time limit, I can highlight only some of our findings, but I'm happy to discuss the full findings after the talk. So for some people in this group, transparency, especially seeing the gain utility values, helped them realize that the division satisfied everyone's preferences to a similar degree, and this led to increased perceived fairness. But for others, transparency confirmed that they did get the short end of the stick, which led to no change or further decrease in their perceived fairness. So this mixture explains only marginal increase here. Let's look at this group who were initially really happy with their outcome. What was interesting was that some of these people, like Kate here, who got their first choice, assumed that the others would have also received an allocation that satisfied their needs. And transparency made them recognize inequality in the distribution for others, which decreased their perceived fairness. Others realized that the outcome that they thought was not as good they had thought. Like this Sean here, who was happy with his second choice, until he realized that there are others who had gotten their first choices. So what should we make of this inversely proportional effect of transparency? I argue that transparency is still beneficial. The ability to judge fairness based on actual overall distribution rather than one's initial assumption is critical for social justice, so that actual injustices can be identified and addressed. Transparency had another surprising effect. So in our previous study without the interface, the algorithm was viewed as solely responsible and blamed for unfair divisions. With transparency, people decreased the accountability of the algorithm and shifted it to data sources, in this case, themselves and their group members. So for example, this person says, the algorithm is just trying to maximizing for you. If something goes wrong, or if you feel it's unfair, that's your fault. Let's look at the effect of control. As we intended, the interface allowed people to adjust the algorithmic allocation to better fit their group's context. And in fact, 22% of the groups did change the allocation suggested for them. What was interesting was that the control also increased the perceived fairness for people who did not change the outcome. Discussion brought a human element into the process because people could see others' reactions or learn that others had kindly tried to improve their outcome for themselves. More surprisingly, control seemed to help people understand the difficulty of the task from the algorithm's perspective. An algorithm automates decisions efficiently, but does not provide experience of actually making decisions for users. Our interface gave people a chance to do the division task themselves, and in some situations, they realized the inherent limitation of the task, and this increased perceived fairness of the outcome. I have now presented how my research addresses the challenges that I explained in the beginning of the talk. What do these mean in terms of enabling smart organizations and cities that are not only efficient, but also fair and trustworthy? This work offers 3 implications for answering these questions. First, my study suggests that we shouldn't treat all tasks equally when we study perceptions of algorithmic decisions. Instead, we need to start thinking about how to include this task dimension in our frameworks. Second, my research empirically shows that it is important to add transparency and control to the algorithms, rather than treating them as black boxes. Transparency helps people judge fairness in allocation, and also had an unexpected effect of reducing algorithms' accountability. Control helps people adjust the outcomes for their context, and surprisingly help them appreciate the inherent difficulties of the task. Finally, my study shows the gap between algorithmic assumptions and actual human behavior, and how critical it is to attend to these gaps for algorithms to work fairly and be adopted by people. And these gaps can be uncovered only through social validation that examine how algorithms are actually used and perceived by people. And this is something that this community is really well equipped to do. So we can work together to push boundaries and theories and to use the knowledge to inform the development of emerging systems and hopefully mediate these gaps. So let's work on building the future together. Thank you.
And so certain kind of human tasks like evaluation were judged as more fair by a person. I'm curious if you looked at, because we know people are biased, right? And there's things like in-group favoritism. So if the evaluator is like me, I get a benefit, and if I'm an out-group member, I'll be judged less fairly. So I wonder if you looked at individual differences, say in terms of, do people see themselves as disadvantaged in general? Would they actually prefer an algorithm because they know that people are biased in a specific way?
Yeah, that's a very interesting question. And actually, I also work with a lot of underserved community in my other line of work. And when we talk about these systems, actually, they do mention that they feel like algorithm will be fairer than humans because they see a lot of discrimination in the real world from humans. So I do think that there will be individual differences, but I haven't personally tested it in our study.
A bit more about, sorry, I think it's coming on. Could you talk a little bit more about what you made transparent? I think it's really useful that you gave people a way to interact versus kind of just informational disclosure. But was it, like, from your perspective, were you exposing the limits of the model, the assumptions of the model, the data inputs? If you could talk a little bit about that.
Yeah, so we wanted to show both, like showing both algorithm assumptions and actually how they are operationalizing what envy freeness means here. So we did our best to explain what algorithm is doing in plain terms, using diagrams and plain text, and then showed both input and output. There were people who did actually look at these assumptions and identify the parts that they disagree. For example, here, one of the assumptions of this algorithm is that the algorithm tries to maximize the product of value, kind of maximize everyone's value rather than like equalizing what everyone gets. Some people were able to kind of point out that this is something that I don't agree, so I want algorithm to more equalize the gain at this second point. But actually, there were very minority of people actually who pay attention to this and make sense. Whereas this table was really effective in kind of making people understand what happened for their specific context. So we tried to do both, and yeah.
All right, so we have time for one more question.
Yeah.
Thank you. My question is about the control condition. So in the social justice literature, there's something called distributive justice, the actual outcomes, and procedural justice, whether you've had a voice or an ability to, to say something about how those have been divided out, who gets to decide. So have you been able to separate whether it's the final distribution that people are happy with, or whether it's just that they had a chance to look at it and get to say that, well, I don't like this distribution, or I don't think this is fair, and which one of those is affecting it more?
It is actually both, because people who, I will not try to find slides, but people who did change their outcomes, they're the one who saw, I guess, inequality in distribution, and they could easily fix it. Whereas the others, they tried it, but they couldn't fix it, or they just saw that people were trying to make it right, and then the fact that they had a voice, they had a choice to say that I feel unfair, and let's try to work on this, that procedural change had a huge impact. So I think it's both